Hey guys, welcome back to Genius Learning. So in this video, I just want to go over another review for derivatives, and kind of an ugly derivative, but after we rewrite it and use some of the properties of ln, we'll realize how easy we can make it. And I forgot to write an ln here. So this is ln of the square root of all that inside. All right, so there's an ln outside. All right, so I'll just probably write it here. Y is equal to ln of square root e to the 2x plus 2x x plus 4. Okay, so this is how it looks. There's ln square root of everything. Okay, so now before we start, let's review some of the properties of ln. Okay, so when we do the derivative of ln of u, we have the derivative of the inside, right, over whatever's inside. Okay, so if we have ln of x, then we're going to do the derivative of whatever's inside and put it on the top, which is 1, right? The derivative of x is just 1 over whatever's inside. So that's why you always see the derivative of ln of x is 1 over x. So if you have ln of 4x, right, the derivative of whatever's inside, which is 4, right, 4, divided by whatever's inside, so 4x. So these 4's cancel and you get 1 over x. Okay, so same thing, constant in the front. So now let's take a look at ln's with exponentials inside. So let me show you what I mean. Let's say we have ln of x squared. Okay, so what we can do is bring the exponent to the front. So we got 2 ln of x, and now it's not squared anymore. Okay, so similarly, if I had a 3 ln of x, I can rewrite this as ln of x cubed. Okay, and one more example. If I have negative 1 ln of x, right, I could raise this, or whatever's inside, to the negative 1. So I have ln of x to the negative 1, right, because the number in the front goes on top to the exponent. Number in the front to the exponent here is backwards. You know, you got the exponent, it could turn into something with the number in the front. But if it's like this, then really what you have is ln of 1 over x. Okay, so if you have a negative on the outside, remember that you're going to make a fraction in the inside of your ln. All right, so I think that is it. Maybe one more. If we have y is equal to square root of x, that's the same thing as writing x to the 1/2. The 2 is the thing on the outside, the 1 is in the inside. So if I have something, one example here, if I have x to the 3 over 5, for example, right, I can rewrite this in root form, knowing that the 2 and this fraction went to the top up here. So whatever's in this area is going to go outside here. So let's write that, and we're going to put a 5 out here. And then the 1 was exponent to the x. So whatever is here is the exponent of whatever's inside. So whatever's up here is going to be the exponent of whatever is inside. So this is important, how to go from fraction form into a square root form, but like you have different exponents now. It's not to the 2, it's not to the 1 like normal. Okay, so let's start. Make sure you guys can see all that. Okay, so let's rewrite this before we start, right? So we know properties of ln. If we have, I should have wrote it over there, but if we have ln of a divided by b, we can rewrite this as ln of a minus ln of b. Okay, so let's do that here. First of all, let's get rid of this root. So we have y is equal to ln of, I'm going to put big parentheses, and I'm just going to put a 1/2. That represents the square root. And on the inside, I have e to the 2x plus 2x. Everything is cubed in here, and then on the bottom of the fraction, we're just going to have x plus 4. So I haven't done anything but rewrite it. I put this square root in fraction form. That's all I did. Now let's rewrite this one more time. So this is an exponential. This is raised to an exponential, and we can multiply those two together. So we're just going to have a cleaner looking thing here with one parentheses that's raised to the 3/2. I multiply the 3 to the 1 and the 2 to the bottom, so it stays as 3/2. I can rewrite everything inside. I got e to the 2x plus 2x divided by x plus 4. So I've just rewrote it again. Now let's rewrite it one more time. Let's bring this fraction, or this exponential, out to the front of ln, just like we did here. This x was raised to the 2, and we can bring it in front of the ln, just like this. So this exponential is going to go in front of the ln. So just taking advantage of the properties, not really solving it yet. We're just trying to make it easier, a little bit easier on the eyes and in the math. So we brought down the exponential. We got the ln, everything stays the same. And then final simplification. We're gonna use this property again because we have a fraction, and we can split that into two things. So we have 3/2 that's gonna stay on the outside of everything. So let's write some brackets maybe. Okay, so the ln of these two fractions, remember the top part stays in the front. So let's write ln with just the top part. Close it off, minus, now we got ln of the bottom part. So ln of the bottom part, which is x plus 4. And then we'll write another bracket to close off, because we still have the 3/2 that multiplies into each thing. All right, perfect. Now you can see that you have an easier derivative for ln in this form, or it may not be if you already could see through these, but I think that knowing how to change these at least once or twice could be helpful. So we changed it 4 times, and then now I want to start. So now let's take the derivative. All right, we got y prime. Okay, I'm going to keep the 3/2. Right. I'm going to take the derivative of these two things inside. So I'm going to keep these parentheses here. Now the derivative of ln, we have the derivative of whatever's inside over the inside. So the derivative of whatever's inside goes on top. So the derivative of all this is going to be the derivative of e to the 2x is going to be 2 e to the 2x, right? Because we take the derivative of whatever's on top, bring it out front, and then times the same thing that we just had. The derivative of 2x is just going to be 2. And then we put underneath what we originally had in the inside. This is what we originally have in the inside, plus 2x. All right, so I may have, let's see, I may have put an extra parenthesis. Actually, I mean, I may have just extended the line. This is closed off right there. And let me erase this line a little bit so we can see that there's a minus sign. There you go. Okay, so now we're gonna do this derivative here. So this minus sign corresponds to this minus sign. This derivative in here was from this ln right here. Okay, so this is 3/2. We got the big brackets, which are the big parentheses here. We did the derivative of this only, and that's that. The minus sign, and now we're gonna do the derivative of ln x plus 4 right here. So the derivative of ln is what? Derivative of the inside over the inside. So the derivative of the inside is 1. Over the inside is going to be x plus 4. Okay, so you could even put a little parentheses around this, and then let's FOIL in this 3 over 2 into both of these terms. Okay, so we're going to do one more simplification here. We got y prime is going to equal, if I FOIL this into this first term, but first I want to take out this 2 and this 2 that they have in common. So I'm going to write 3 over 2. Okay, that's going to be multiplied by this entire parentheses here, but on top I'm going to take out a 2. So I'm going to take out a 2 from the top, and what I'm going to have left here is just e to the 2x plus 1. Everything is still being divided by all this, so e to the 2x plus 2x. Put parentheses around that. Okay, now we have minus, and then this multiplies into this second term here, so we're going to have 3 over, let's put it bigger, over 2 parentheses x plus 4. Alright, so I multiplied into the 3 to the top because it was only a 1, and then 2 to the bottom, but I kept the parentheses around these two. Okay, so let's see. The only thing that we can cancel, yeah, I think that's pretty much how we should leave the answer, but let's cancel these two out before we do that. All right, so then the final representation of the answer is going to be y prime 3 parentheses, we got 2x plus 1, all right, over e to the 2x plus 2x. All right, and then here we got the same thing, 3 over 2x plus 4. All right, and this is it. So what we needed to do here is realize that we have a lot of properties for ln, and so instead of looking at this and beginning from how it looks, if you take advantage of some of the properties and just break it down, then you might have a very simple derivative on your hands that looks very intimidating on purpose. So if you try to take the derivative of this, I mean, you can, you know, but it's going to be a lot of algebra that you want to avoid. So one of these is fine, 3 of them is even better, and just try to take advantage of all those. All right, so that's it for this derivative. I'm going to show a couple more in the upcoming videos. Thank you for watching.